All right, so now we're live. So today we'll talk about two issues. One is a data type that our friends in the other SDK have built, and they would like to put this into the BCL. So I'll let Christoph talk to that. And then the second one is tenors, adding more half methods, which should hopefully be fast. So, Christoph, do you want to give us the overview?
Sorry, you asking me something?
Yeah. I was basically just saying, do you want to give us the overview over what you're trying to achieve?
Okay, definitely. I just hear this hissing sound. I don't know why nobody else hears it, and I already restarted my Teams, but anyway.
Oh, I hear it. It's Emo's laptop fan. It's trying to take off.
Oh, okay, nice.
I see what's happening here. So you are... we are the wrong... Yes, of course, the internal microphone is again connected. So let's try this one instead. How's this mic?
Okay.
Here we go.
All right. So, okay, so let me kind of a bit of a history. So we have lots of APIs in the Azure SDK that basically move data between the client machine and Azure. So, you know, there's storage APIs where you can literally, that's all they do. They store, you know, binary data in blobs, for example. There are various messaging APIs where messages usually are, you know, either text or JSON, but fundamentally, you know, the protocol moves bytes around. And so far we've been designing these APIs by taking either read-only memory of bytes or byte arrays and returning read-only memory of bytes or byte arrays. We had we discovered the problem, usability problem, that some users, it's not like it's a complete blocker for them, but it takes them, you know, a bit of time to figure out, I want to store, let's say, a string in the blob storage. What do? How do I convert a string to bytes? I want to store an object, just serialize it. How do I serialize it? And as I mentioned, it's not a complete blocker for them, but there's a lot of ceremony around converting strings to bytes, and on the way, you know, out bytes to strings, even more with serializable objects. So you need to somehow get an instance of a serializer, then you need to, you know, serialize, then the users are thinking, do I need to delete the serializer, store it in a static, is it thread safe? And there are so many of these questions that they have. So something that should be super simple, like storing a string in a blob storage, you know, takes disproportionately longer time. So we came up with this idea of adding this type called BinaryData, and Emo has it on the screen. If you can, maybe for now you can just remove the comments. So if you click on the right top where it says 3/4, Emo, clearly you're not listening.
Emo's screen sometimes doesn't cooperate as well.
Oh, really? Okay.
Yeah, it's entirely possible he doesn't see the comments anymore.
Yes.
He doesn't hear what I'm saying. Anyway.
That's new.
Yeah.
So anyway, yeah, I wanted to kind of the whole type show up on the screen, but so we designed this type, and we've had it for some time in a prototype stage. And over time, it got kind of better and better. We ran usability studies on it, both as a standalone type and in the context of some services. And we made some tweaks. And the most recent usability studies were super positive. And to a point where we started to think like, geez, should this type be in the BCL? Would it be more applicable in other scenarios? So why the type works? So imagine that you have a method, let's say in storage APIs that takes byte array. So upload, and it takes a byte array. What we would see in usability studies, people would be, okay, I have an object, I need to serialize it, and I need to pass byte array. Or even worse, let's say the input APIs take a stream, which actually for storage, they take a stream, not a byte array. And suddenly the user kind of needs to figure out how to instantiate memory stream, wrap it around JSON serializer, serialize the object into the stream, and then pass the stream. Actually reset the stream to the beginning, and then pass the stream to the upload APIs. The moment we added overloads that take binary data, all these problems went away. Basically, users see in a signature type binary data, and as you know, the first thing that they will try to do is instantiate binary data. So they kind of new up binary data. They notice constructors. They look through the, options that the constructor offers, and they see that it takes JSON serializable object. Okay, great. So they just pass the object that they have. We serialize it to JSON, store it in a byte array, and then when it gets passed to storage APIs, we just send the byte array across the wire. And similarly on the output. So in APIs that don't use binary data, we would return, let's say, read-only memory of byte to users. And that is still very confusing. You also probably realize not many people understand the new memory primitives. But even if we return a byte array, people still have problems because, again, they have to instantiate the serializer or know how to use encodings. People get confused why we have both encoding and encoder and which one is which. For us, it's, super kind of natural because we've been, we work on these APIs, but a lot of people still get confused how to convert bytes to strings. So imagine now that the API returns binary data instead of a byte array. And suddenly, if emo scrolled on the screen, emo,
Oh, wow. That's some white glove service right there.
Yeah, keep scrolling so we can see all the two methods. But basically, the type has methods 2 bytes, 2 object, 2 stream, and 2 string, and they basically provide a super convenient, exactly. And they provide super convenient methods to, convert the bytes into whatever the user is looking for. So as I said, we ran usability studies, and literally they were, night and day from the previous studies without this type. We got a lot of good feedback. Users were asking us when this type gonna be available. And then we started to have a discussion, as I mentioned, should we ship it in the BCL? Thus the discussion that we have today. Of course, it would need some modifications. So for example, we have method overloads that take object serializer, which is our abstraction that lets people switch between system.text.json and other serializers like Newtonsoft. This type already shipped in Azure Core, so we wouldn't use it. We would just remove this method from object that takes object serializer and same to object, and either make them extension methods in Azure SDK or just have helpers. So that's and one additional complication is the schedule. So we have some service libraries that will be shipping maybe in a month and a half, probably month to month and a half, and day to day depend on this type. We would prefer not to change the APIs of the service libraries, but if that would be required for collaboration with the BCL team, what we would do is we would remove APIs taking dependency on binary data, and then just add overloads later. Properties is a bit harder when the return type would have to change, but we would add a property with a suboptimal name, and then a couple of months later add a property with the appealing name. So that's roughly the story.
So I have one question. So besides the thing that it's, sorry, like there's some echo. So like besides the thing that it's obviously the right thing to do, the question is, what benefit would it give users if this thing ships in the BCL?
Mm-hmm. Yeah, so I think that the main benefit is that if a type is in the BCL, it can be used in other third-party libraries. So think about Azure SDK as a third-party library, and it would make third-party libraries better and easier to understand, because people would over time learn there's this thing binary data, and whether they are looking for APIs in Azure SDK or in ASP.NET, frankly, not only third-party libraries, but in ASP.NET or other libraries, you would have this type, and it feels very natural. If it ships in Azure SDK only, either ASP.NET wouldn't have a type like that, or it would have a different type, which potentially could introduce confusion. So I think that's the main benefit, because I don't think we can take this type low enough to actually use it inside BCL APIs. So, well, I don't know if you consider now ASP.NET APIs BCL, but it could be used above system text JSON, but not below.
Right. So, I mean, one concern that I have is the to and from object, because basically that would be saying that we believe JSON is the right answer until the end of time, because we can't change what the zero argument thing ever does. Or we can't, the one that you don't specify a serializer to, and I don't think that's the right answer for the BCL, because we've seen serialization formats change rapidly. Like if the protobuf or other tightly packed things start taking over, we now have this wart of JSON in the middle of a very, essentially this is introducing a new lowest level type, or it's not a ref struct, so just above span.
Yeah.
And so I'd be concerned about the to and from object. The to and from string feel like they do need to support custom encoding, and the stream, or wrapping a stream, seems very weird, because this is all synchronous, like the synchronous to array, but you don't know if you had a stream, at which point you may need to be async, otherwise you're introducing sync over async. So my quick glance here feels that this it makes a lot of API simple, but the way that it makes it simple is by bringing back a lot of problems that we try and avoid having.
Well, so let me go one by one. I think the serialization issue that you brought up, we would solve it by adding an overload. So today we have this overload that takes object serializer, and it controls the serialization logic. So in fact, I was saying this is to select serializer between system text JSON and other serializers. It doesn't even mean other JSON serializers, because object serializer just has a method serialize.
Right.
So that is currently the way to control what serialization technology you're choosing. And if your concern is, but there's JSON, system text JSON, that is the default, I would say trying to avoid defaults too hard, because in several years they may change. I don't know if that's a good way to trade off usability between usability and kind of future proofing. I agree with you that if it was a potential word going forward, then yes, it's a much bigger concern. But just having default be different in the future than what would be an expectation, I think that's fine. Otherwise, you're designing APIs that just don't have defaults.
Well, because this feels like it's used for data persistence, which means you need whatever a default to object does and a default from object, they need to do the same thing, and that needs to do the same thing across versions. So I think that once we have a default, it can't ever change because it's for data persistence. It's not just in proc.
Yeah, that's what I was saying. So, but I would not avoid having defaults because they, they potentially, the expectation of what the default is can change in the future. Otherwise, you're basically designing APIs that have more and more parameters because you're being, super scared of choosing a default that will not last forever.
I mean, I like the notion of simplifying something of here, I'm some binary data. We're going to deserialize it. We've made some level of a very, very simplified, I guess at this point it would have to be an interface for serialization of, or it would just be a wrapper type of, here are some bytes, give me an object. And if it required configuration, you had to have done that on the instance already or the instance that you gave to the wrapper. And that totally makes sense to me. And then that we would need some good singleton somewhere so someone could say from object, default JSON or whatever. But then it says in their code and they know that they're dealing with JSON as their persistent format instead of in 3 years protobuf compact format is the de facto standard, and somebody's looking at something and like, well, why can't I read this payload? Oh, because you're reading default and we wrote it protobuf. I'm concerned that the serialization format's not going to change in like 10 years time. I'm concerned it's going to change in like 2 years time.
Well, so it will not change in 2 years.
Well, over the course of .NET, .NET is 20 years old. We've changed serializers 3 different times. We've had a total of 4 primary serialization formats in .NET. So that means on average, they're changing once every 5 years.
What do you think were the 4?
Binary formatter, XML serializer, data contract serializer, system text JSON. Those are the 4 primary ones that we tell people all new data should be persisted in this format.
Well, wasn't data contract serializer just a different take at?
It had a different capability set.
Sure. So
but it was still XML.
Yeah.
No, it could do JSON as well.
It could, but by default it did XML.
Default did XML, but it did it differently. It did it in an incompatible fashion when compared with XML serializer. If it's incompatible, that means it's a different serialization technique.
Yeah.
Fair enough.
But anyway, so maybe it will change in 5 years or maybe in 3. The thing is that I'm still not understanding, is the concern that there is no way to switch the serializers, which I'm saying there is, or we can add, or that there's a default. Those are 2 separate concerns, and I don't understand which one is the.
So I think that if it's added to the BCL, it needs the option of putting in your own serializer because we've seen enough people wanting to tweak the JSON serializer that's going to be a minimum requirement. And then, but then I feel that it's going to be one of those in a few years, whether it be 3 or 5 or 20. We're going to be like, why do we have this thing that defaults to JSON? It's such old broken tech, and now we can't like drop it out of the standard reference set because we can't move it to optional because we need this because it's the default.
And it needs to be in private cloud now.
Yeah, and we never. Oh yeah, that's true. It would also require moving JSON super far down because.
No. Why?
Well, it depends on how far down we want to use this type.
Yeah, exactly. That's what I'm saying. So I don't think it needs to be very low, or it should be, because I mean, if it has a dependency on system text JSON, it cannot be super low already, correct?
Right, but if it had no default serializer, it could go lower, and somebody at a higher level just says, "I made an I serializer out of system text JSON, and I'm throwing it at BinaryData and go." And so you've decoupled the technology. It only depended on an interface or an abstract base class that we throw somewhere down low that had no notion of what data looks like. It just has you give me a T and a some form of data, and I produce an object.
Yeah. So I would say, so again, there's I think now 3 issues. let me answer this, the second one, the one that you were saying that in the future, the default will not be what people expect. I see it as, the perfect becoming enemy of the good, because there's no solution to this problem. Basically, if you say, we are afraid to have a default serialization format because it may change in the future, then it means serialization format cannot be defaulted. And that in turn means that the APIs are not simple because you have to keep passing some implementation of some abstractions, or which literally is a very severe usability issue. Whenever users see an abstraction as a parameter, they don't know what subtypes implement the abstraction. They potentially can be even in different assemblies or NuGet packages. So I think, again, having defaulted serialization format gives you the usability that this type is designed for. And yes,
Sure.
in 5 years, it may not be the most expected serialization format, but as long as we have a way to switch, I think it's a good trade-off.
Sure, and I want to get back to something that you said earlier, actually. So I think we were under the impression that this would live in private corelib because it's an exchange type, and generally we want types that are in private corelib not to be opinionated. But it sounds like you actually saw this living somewhere higher up in the stack. Can you kind of go over that a bit?
Yeah, so as I was saying, I think that this type is for basically things above the BCL. It's for ASP.NET, for Azure Core, and other libraries that build on top of .NET. It's kind of similar. Recently, we've been working on, or I didn't participate much, but you guys have been working on the helpers for HTTP client that do similar things automatically. And those are higher level libraries, and they do default to system text JSON serialization.
So are you thinking a JSON specific named package that you have to import and add a using for? And
but are you thinking that this might be like a Microsoft.extensions thing?
No, I think it. I mean, I would just add it to basically it's. I was talking with Emo a couple of days ago, and I was saying maybe it should go to system text JSON package actually. That's one possibility. But I would not put it as Microsoft. I mean, we wouldn't use it in Azure SDK if it's in some Microsoft extensions.
So my only concern is I completely buy the default argument. The only concern I have is that it seems a bit weird to say we don't want to pay the price for some sort of switch that you can pass to the constructor to construct the type, and simultaneously say that well, if you ever change the serialization technology, then we will add the switch. Because I think the question isn't so much whether we will need to do this, the question is just when we will need to do this, right? And so eventually you will have to pay the price of this API that allows you to say, oh, do you want to use system text.json or the new shiny, switch to rule serializer that we added in .NET 7. And so then the question becomes okay, at that point we will have to pay the price for having that, or live with the fact that this type just doesn't support the serialization format at all. And do you think that would be acceptable, or do you think that then we just have to take a breaking change and actually change the serializer?
So again, you said that we wouldn't be able to support this other format, and
well, I mean, it's basically we have two options. We can either say the constructors or factory methods that do serialization on your behalf take some sort of object, or not object, but some sort of switch that allows you to say use this serializer. Or we are saying, no, it's always hardwired to system text.json. These are really the only two options, right?
So this is we're discussing this, I don't know, maybe I'm not explaining it well. Today, we would default to system text.json. In the future, we, of course, have an option to support other serializers.
Right.
By adding a switch. So there's no, you basically, the the phrase you said is we wouldn't be able to support some other serialization format in the future, and that is not true. We will be.
Sorry, like I mean, what I meant is like you basically said a few minutes ago, like on the one hand side, you're feeling strongly that we should have defaults because it's a major usability bump if we don't have a default serializer. And it sounds to me a little bit like you're objecting to having some sort of abstraction like object serializer or an enum or something that allows you to specify the serializer. And so I'm saying I'm a bit concerned if we say, okay, we need to have system.text.json as the default, but we are also kind of acknowledging that probably it's not going to be the right default forever, right? And so the question then becomes, once system.text.json is no longer, the new shiny thing on the block, then what are we doing with the people that are not able to, I guess, pick the right overload?
No. So at that time, we will add an overload, and I would do an overload that takes probably an enum, not an abstraction. In addition, there should be an overload that takes an abstraction once there's an abstraction, because it provides the ultimate flexibility at some cost of usability. But when we have a different serialization technology that we want to support, we would add an enum overload, and the enum would say system.text.json and whatever serialization technology of 2020, 25, let's say. And that would be the way to support the new serialization. So that's issue number one. Can we support new serialization technologies in the future? And I assert yes. And I hope everybody agrees that it's yes. Now, the second question is, is it weird that in 5 years, the default will be not what people prefer?
Right.
And to that one, I would say, I would have to end, like they are not mathematically provable, but I would say, and they are more like, opinions or trade-offs. I would say one, I suspect JSON will last longer than, the 3 or 5 years. So that's one thing. But at some point, maybe, in more than 3 years, it will, there will be a new technology and people will want to use it. And at that point, when we have the enum, passing additional enum value saying, I don't want this serialization and what I want some other one, it's not a big deal. If we don't have a default today and we just add an enum, we would have an enum with
just one memory,
one value. Also, I think having types be simpler when you ship them for the first time is more important than longer term. So whenever a new type or like an exchange type is introduced, I feel like it's better for it to be super simple and then add features as we go, as people kind of learn what this type is about from very simple view like this one. And over time it grows. And it's, sometimes it's not ideal, but it's not such a big deal as shipping from the get-go something more complicated. An example, I mean, there are many APIs like this in the BCL that started super, super simple. And then over time got more complicated, yet users report less and less usability problems with them as years go by, because people just got used to the types and they know how they work. And additional complexity, they kind of like, I guess doesn't even show on the radar. So
yeah, I don't know if I don't know if I would want to say that this is like a base exchange type if it's so opinionated that it uses system.text.json with a very particular set of configuration. But it's if we said like that this is a, and I think you had said this earlier, but please correct me if I'm wrong. If we say that this is a type that allows more easy usage of things like system.text.json alongside a bunch of other primitives, but it itself was not a basic exchange type, I think that might be an easier pill to swallow. Because I think when we hear basic exchange type, we think like core BCL, we start plumbing this absolutely everywhere in the framework.
But by the way, I never said basic exchange type.
Well,
Okay.
so it wouldn't be an exchange type in the BCL, right? So that's the other thing I discussed with Christoph, right? So the way I see this type is, um, it's more like a holder for a byte array, and then convenience methods to do conversions, right? That's really what it is. It basically ties all the ways you can represent binary data and provides to and from methods effectively on it, right? And so it would be an exchange type above the BCL, right? You can think in the Azure SDK or an ASP.NET or Microsoft extensions or, things, for example, or extension methods for HTTP client could be in a similar bucket, right? They're very high level APIs in the sense that they depend on fairly large blocks of the BCL. But we would never be able to, let's say, add overloads on stream that take binary data, which we believe is acceptable because fundamentally we already have exchange types for binary data, right? That's read-only memory, it's read-only span, byte arrays themselves, right? And so the idea here is that's more like a sync to give the user one way to effectively represent binary data on their end and still be able to call every API that exists, right? And so it's more like a utility type that allows you to convert, right? That's really what it is. And yes, it has a cost as well. So I wouldn't, for example, expect low-level things that need to be super fast to use this type either, right? For example, if you take Kestrel, given that most of these conversions actually involve copying data, it is not super cheap, right? But that's the price you pay for having a unified representation that people can easily reason about, right? But it would unblock large chunks of things where performance isn't the higher order bit, and people just struggle with, oh my god, how do I get a read-only span of byte out of a string, right?
Yeah. Like people, and I think Christoph hit at this really well earlier. People just want to get their jobs done, right?
Right.
Like they don't care about avoiding every single little copy, because for most applications it just doesn't matter.
But basically, my point is like because we have these conversions, we also don't have to, right? So like there's some things we could do. The type doesn't do that today. I guess similar for the reason why we don't have a implicit conversion from read-only memory of byte to read-only span of byte. But we could have implicit conversions to byte array, read-only span of byte, read-only memory of byte, right? And so you could basically pass this API to anything in the BCL that does take bytes. And that's probably good enough for it to act as an effective exchange type above the BCL.
Yeah. So because I need to actually leave at 11. So let me go to the second issue that Jeremy raised, which is toString and from string should take encodings. So we explored that, and I don't think anybody has fundamental problem with this. If this is something that is super important for the BCL team, I don't think we have a fundamental problem. The reason we didn't do it is that, frankly, we don't see scenarios where anybody would want that. And it may be because we deal too much with networking, but literally people either have strings and they're always strings, or if they convert strings to binary, they want UTF-8. We literally don't have other scenarios, and we haven't encountered them. So adding an overload that takes additional parameter was, just adds to the surface area for no actual scenario reasons that we could figure out.
Really, it's just for standardization of all of our low-level things that turn strings into bytes, take encodings.
Yeah, but I mean, but the implication is that it does complicate the object model because you say new binary data, and suddenly instead of 5 constructors or 6, you have now 7. So there's more to scroll down in the list of possible overloads. And as I said,
I actually agree with Christoph here. Like if the type's already opinionated, then sure, the opinion is UTF-8. If you want a different encoding, turn it into bytes yourself and then wrap it.
Fair enough. And yeah, I think the sync over async, I think I understand more the model now, which is all of the from methods / the constructors are data syncs. It's not holding the stream reference. So it's going to drain the stream as soon as you call it. So you called from stream or from stream async, and then you dealt with it at the building time. So effectively, this is just using a byte, or it's turning everything effectively into a byte array, right?
Correct. Yeah. I mean, there's still a sync over async issue because we read the stream synchronously in the synchronous version of the method. But I would say.
But that was the caller. They could have called from stream async.
Yeah, exactly. Yeah, true. They basically decide which way they want to read. Just like if they read from stream, they can just use sync APIs to read from stream, and there's exactly the same issue.
Yeah, I was concerned that this was basically just being a union type with delayed processing, and therefore that 2 bytes was where the stream was going to be read. But if all the froms are data syncs, then that makes more sense. I mean, it's a little sad that that toString is going to take whatever data is there and UTF-8 it and spit it out, because if they built it from a byte array already, it's like that's what the debugger is going to print unless we slap a debugger display on it. But and it's probably garbage unless it actually came from a string. So that's a little weird, but
yeah, and we wouldn't want it to throw because it's toString.
Yeah, yeah, as far as the serializer, I mean, we'll see how it gets there when we get there, but if it's at all in the shared runtime, I don't think an enum will happen because the trimming can't trim out if you do a switch on an enum. So, Steve would say to JSON and from JSON should be one method, and to protobuf would be another method, and then you have the one that takes you give me an object and that told me what we're going to keep in for the trimming. But they wouldn't want the switch off of an enum because that means that all of those possible code paths have to stay in once you've called that overload.
Yeah, so this is possibly the reason why I think this is not a system runtime type, because it basically would result in yet another low-level type that is not super usable, that represents bytes, and we already have those in the very core BCL. What we don't have is this type that basically provides, usability layer on top of those.
So in the types that you're currently building in the Azure SDK that want to use binary data, are you also overloading them for other things, or are you deciding that in your APIs this is the new way that you want to represent all possible inputs of data?
So we don't yet know. Well, there's an issue of, are they inputs or outputs? So of course, if they're outputs, like we are designing now service bus library that is close to shipping, and outputs are only binary data, and inputs I actually don't remember. But to directly answer your question, we don't have yet enough experience with what would it mean to use this type as the only type in the APIs. Let me try to find the
right, because I'm just trying to think ahead of what if this gets added in the middle, right? So let's say it's the first thing on top of what we classically think of as the BCL. And so now you have high-level things take this thing called binary data. People understand they get a binary data and whatnot. And then they need to move and do something with cryptography. And now all of a sudden they need to go back and understand span and memory and byte arrays and streams and what are the implications of all these various different things, and at what level, like, should they have even skipped the binary data and passed the stream directly into the crypto things because there's an overload for that, and maybe it makes sense, right? So it just feels that it's making this weird, like, I didn't turn my camera on yet, I'm gesturing to it, that high level types use this unified model, and primitive types are now even harder to use because you've removed their familiarity with these other concepts.
But hasn't Christoph already solved this to a certain extent by having implicit operators where appropriate? There's an implicit operator to ROM a byte here, but you could imagine one being to ROS a byte as well. Pretty straightforward.
Yeah.
Exactly what I said yesterday. Yeah. I mean,
I assume the backing field for this thing is a ROM byte. Like it would have to be in order for that operator to even make sense.
I assume it's bracket, but
Yeah.
I think it's byte array today, but I guess the question really becomes like, I think to me that would be the desired outcome, that this thing has implicit conversions to the most important things. The problem with those is that people have to know that they exist, right? So we still have this problem that if you call, let's say, stream.write, that takes, everything but binary data, that you have to basically know that you can pass that thing in, right? But to me, that's kind of the value of adding it to the BCL, because we can actually blog about it and make sure people are aware of that type, and basically raise it as this is the way you should design high-level APIs. And then I think it's also okay if high-level APIs don't take, span and byte and all the other ones, and they only accept binary data, because realistically the high-level APIs pass this thing down anyway, and the low-level APIs are the ones that actually need the bytes, right? Not the high-level APIs.
Yeah. So yeah, exactly. I was about to answer Jeremy's concern, and I would say, I think trying to teach everybody how to use span of bytes is basically a bit of futile effort. And it's great that our low-level APIs use span and ROM, but it's fine, I believe, for people who integrate those two layers to basically fish out ROM or span from binary data. And like, trying to basically teach people, no, we're gonna teach you how to use span and ROM by not providing helpers.
Right.
So go ahead and learn it. I just don't think that's a good strategy.
Well, that's my concern of having this as too high of a level, that there's essentially shearing of people who only understand high level, and then they can't go below this line. Did the usability studies you do involve also needing to take one of these and send them to existing BCL APIs that don't take binary data?
Correct. And basically what people do is either call, so ToStream was very popular for the integration point. And then there were some where they actually required people to understand read-only memory and how to integrate that with, array APIs, with span APIs, other APIs. And then, yeah, there are those scenarios, and people do struggle. But people do struggle, but none of those were complete blockers. So, people continue being surprised that read-only memory doesn't have an indexer and some issues like this, but it wasn't complete blocker. But as I said, we're not gonna solve this problem. These two types, ROM and span, will forever be a bit exotic, I think, to half of our developer base.
That's I'm just trying to think of the concerns of putting it as the highest level in the BCL and having a sheer line of complication.
Yeah, but the trade-off, again, going back to the trade-off is, if you want to put it down in the BCL core, it would lose usability, because then you cannot have dependency on all these transformation routines to JSON, to to JSON mainly, but in the future to other serializers. So
that's fair. So so if we think it can be successful as a top of the BCL or bottom, or I'll go with top. Depends on which way you draw your diagram. Then looking like, I do wonder if we would still want to take the from object that assumes JSON and just go ahead and call it from JSON, and so it's just like straightforward telling you what it's doing.
Well, the problem, so we could consider that, but from JSON is not actually saying what it's doing, because the input is not JSON.
You'd actually want the toJSON method returning a binary data, which is a bit weird compared to all the other two methods.
Fair enough, because yes, it's from an object, so then it'd have to be called from object to JSON, which is wordy. But yeah, I mean, I guess if it's if it's a high enough level type and people say it doesn't trim well, then we'd shrug and say, then don't use it.
Yeah.
Or at least that if those methods don't trim well, we'd shrug and say don't use them. But I do expect that there would end up being, just trying to think forward of how we would do it. I think that it would be like, well, if I want to do JSON, I don't end up needing this, or when I trim, it drops out protobuf and bson and cbor. But the moment that I want to do cbor, it now pulls all of them in. Why can't we have a method that does cbor without needing the enum? And I feel that that sort of request would come along, and that putting the data type in the name that asserts what data type it's doing will help, but I also agree it's verbose. Of course, I think Christoph Swalina has a nice quote in a book that says, "Don't be afraid of verbose names."
I also can have answered to your question. How could we get best of both worlds? If we had the C# feature called extensions everything, if we could constructors be extension methods and static methods be extension methods, then we could basically get what you want and usability.
I mean, that was my question yesterday to you. Like, I mean, imagine we would not have any constructors and everything would be factories. The nice thing then is also we can name things, so that's kind of more amenable for extensibility. So that still doesn't buy us, of course, static extensions, but you know, we could imagine a world where we would have static extensions, and then having static factories would basically allow us to push this type further down.
Yeah. So we tried that. So we as I mentioned, we extensively studied usability of this type, and we tried several combinations, including only static methods, less constructors, more constructors, various combinations. And unfortunately, we discovered that, as you know, people try to just instantiate types and find constructors. And if they don't find them, it is a big, it basically blocks them for literally 10, 15 minutes trying to search around how to instantiate this type. And especially that it's a struct, so it has the default constructor. So let's say there are no constructors. They find the constructor, they instantiate it, and now they are like, okay, how do I put data inside? And they cannot find any methods. And like, so the moment we added more constructors, and yes, some methods, the async methods are still methods, and there are no constructors equivalents, constructor equivalents, but they are kind of more, I would say, advanced. So what people what we've seen in usability studies, that would start using constructors, and then over time they would learn about this type, and then they would discover the static methods. For example, initially they instantiate it using constructors, they call instance methods. From time to time, they are like, let me see what's the shape. This type seems to be kind of useful and showing up in a lot of APIs. Let me go to, its definition. And then they discover they learn over time the whole shape. But when we didn't have constructors, it was very confusing because of the issue that I mentioned.
But
that
like
matches what we've seen too.
Yeah, I mean the serializy ones could maybe get dropped out because the serializer extensibility is the plus trimability is the sort of the complication. And
but unless we have static extension methods, we don't get any benefit from wrapping the constructor.
Right. I mean, this is more like a question of like how could we design the type, right? The other concern that I have is if we go with factory methods, I would probably not have any constructors, because as soon as you have some constructors, people don't look for factory methods anymore, right? So if you have no constructors, or you have, and everything is either a factory method or like an instance method, like a set or something, I think you have a much higher chance of people looking elsewhere. Because as soon as you have an overload that takes a byte array, people assume that's the only way you can construct the type.
Right. But that's fine. They are so. What you said, basically, we cannot not have static methods. Do we agree? Because basically,
there are some async, yeah.
Because async. So we have to have static methods. So then you're basically saying, since we have static methods, we cannot have constructors. And then basically you run into the issue that I mentioned. It's a struct. It has to have a constructor. People find the constructor, and then they are confused what to do with this type.
Well, that's what I'm saying. To me, like the one other option that we have is, instead of having a constructor or a factory method, you could just have an instance method that just sets the byte array.
Well, then this type is not. So today the type is immutable. You then end up with a mutable struct, which has its own set of problems.
Yep. Yeah, we don't. Once it has a setter, then it's a class, and once it's a class, it doesn't have a default constructor automatically, and then we don't need the setter. So.
Yeah, it's just a function of like how you discover these things. I mean, that's my other question. Like, does it have to be a struct? If this is a high-level type, do you care about the extra allocation?
I wouldn't. So we care unless it causes a problem. So the problem that you mentioned, that now people don't find the static methods. As I said, we did actually seen a lot of evidence what's happening here in usability studies, and the only things that are not constructors are the async methods. So
well,
async
from stream. I don't see the stream one in a constructor. So from stream and from stream async are both static method only.
Sure. Okay, so from stream, which by the way we could add a constructor that takes a stream. There's not, but basically fundamentally we cannot have async constructors. And then this is what we observed is people don't look for async APIs on this type anyway. But once they learn the type, over time they kind of keep using it, and they go into the API view and look at the types. They discover that these methods are there, and and kind of they learn over time. So we basically my answer would be, it's not really important that the additional methods that are only factory methods be super discoverable. Like, at least we haven't seen a reason where we were testing users and we were like, geez, they cannot find these static methods. What do we do with this thing?
But then the litmus test is, to me, object serializable. Like, are you okay with removing that one and making that a factory method only?
The one that takes object serializer?
Yeah. Oh, sorry, the one that takes just the object serializable.
Yeah, the one that takes object serializer is already not a usable method, because it's an abstraction and nobody knows what implements this.
No, not that one. The one that just takes object JSON serializable.
Oh, no, that needs to be there. What is the concern with it?
Well, that's basically the early argument, right? So if we could make that one a factory method, and if we could make extension statics, then you have a fairly low-level type. It's a lot of ifs, but like that would basically be the ideal design.
If we had extensions, statics at least, or everything, then maybe. But guys, I unfortunately need to run. I have a skip 101 that would be not good for me to miss.
Yeah, thanks for walking us through this.
Yeah, so I would be, maybe you can chat a bit more about it, and we can chat more together on Thursday if we
sounds good.
Want to. All right.
Have a good one.
Bye-bye.
So I don't know whether you guys saw that, but like I basically created an issue while we were talking, so I can copy and paste the notes that I have into this issue, so it shows up in the regular format.
Okay.
Yeah, I mean, I'm really just trying to think of what comments like Steve would be giving if he were here, and that's I would say, or Eric, since he joined but then he already left, about just the future extensibility of the serializers and the trimmability thereof. And I think it'll be very weird if we have a constructor that does JSON but no one wants JSON anymore, and because I mean, I know that we sort of cynically said now we're adding support for JSON, so clearly it's on its way out, but like there are now a lot of things that are trying to compete to be the next the thing everyone uses. And so I do feel that is way shorter than the amount of time between XML being the hot new thing and JSON being the hot new thing away.
Yeah, and it's also kind of interesting because the one company that's dominating all of the standards committees is also the one company pushing for a different protocol format for use everywhere. So it is very likely that in the next few years we'll see those formats take off.
Yeah, I mean,
Was that sufficiently vague?
I mean, my general concern is, or my general, I think, take on this is that .NET Framework wasn't exactly a fast-moving stack, right? And even there, as you said, like we kind of iterated on serialization a lot, right? And I feel like the speed is only going up, right? We ship more frequently, we are more interested in web technologies than we have been before, and that stuff is evolving fast. So like I have zero trouble believing that in even 2 years from now, there's more than system text or JSON people have to care about. And then eventually you I mean, maybe not CBOR, but like, something like protobuf or, whatever, like with gRPC, you could totally imagine that one is way more important than our JSON stack is, right? And so my concern is if we have a type that is super optimized for JSON and it works great, but it has a super steep falling off for other things, then we cornered ourselves pretty badly with the design.
Right.
But I mean, I think to me, like I buy all the usability arguments, and I even buy that this type doesn't have to be low level. Now, I'm not sure I like the fact that the type depends on JSON, but I can at least see a venue with extension statics and how we could make this a bit more pluggable. And
right.
Yeah, I mean,
this is my just like if we got rid of the constructors that did serialization and we made them only be factories, and we named the one that doesn't take whatever the serialization abstraction is, from object to JSON, and then it says the JSON-ness in it, and then it's not that we gave a default, it's we gave an easier to use one.
Yes.
And so that's the direction that I would like to go, I think, and then that also works for, the make things nice and trimmable is when you call from JSON, it doesn't need CBOR and protobuf and YAML and every other thing that you can think of. But then when you call the protobuf one, it conversely doesn't need the dependency on JSON anymore.
Right.
And we could add one that has an enum that has poor linkability, or we say we have these simple ones, and then whatever abstraction we come up with for give me a tuned serializer, and I will use it.
Yeah, I think we have to reopen the discussion with the C# team, because I think extension everything doesn't go anywhere because it's too costly and too expensive of a feature for them to build. I'm personally okay with if we just have extension statics, that would get us a lot of the problems solved that we have today. Like, I mean, to me, the two things we have asked in the past, which was extension properties and extension constructors, we mostly needed them because of compat, right? Because we wanted to take an existing type that was designed for the .NET Framework days and basically break it apart without breaking source compat. And in that world, yes, you want extension everything, but that one is no longer really our goal. And so now for the new world, we just want to say, okay, we want to design APIs that are usable but also composable. Then we can say, well, okay, we don't have constructors, then we only do, statics, and that works fine, right? And then we can just say, okay, the only thing we really need from the compiler team is a feature that allows us to inject statics into another type, which arguably you don't even need language support for that. I'm totally fine with saying there's just some custom attribute you put on the type plus the method, and then the compiler does the name lookup. It wouldn't be
the definition of language support, Emo.
Well, no, I'm saying you don't. The problem in the past was we couldn't agree on syntax, because if you try to define properties and events and constructors, what is even the language syntax to encode them, right?
Right.
And so, but if we just scope it to all we need is extension statics, you don't need basically language changes for that. You only need effectively name lookup rules changed, right? And then say the syntax is you use a custom attribute, and that solves I think most of the hard problems we had. It's still not as great as extension everything, but I think I can convince myself and some people on the C# team at least that extension everything is probably never going to happen. So we might as well do a targeted feature for that.
My gut on extension everything is extension fields are very, very, very complicated. And once you have that, you can't do, or if you don't have that, you can't do properties or events because they're essentially more object storage. But extension statics does seem easy because it's just sugar.
Yeah, I mean, extension statics are literally just lame lookup, right? I mean, even extension properties, I don't think it's as impossible as you painted, because in the past, what people have done is you just have a conditional weak table and you just attach state to things. And very often you can also get away with don't even need new state, because you wouldn't just have a new property that just combines state of other properties, which is what PowerShell is doing, for example, with their, what is it, annotation properties or whatever they're called. And so you could do things there as well. I just don't think that to me is more niche at this point, because we don't do these decomposition of existing types anymore, right? It's really more about forward-looking stuff if we want usability and composability.
Yeah.
I mean, another option that we have is, just better IntelliSense. I mean, that's another problem that we have today, that if you have constructors and factories, how the heck do you construct, how do you discover the factories, right? And if the factories are on the same type, then you're somewhat in luck. But even then, IntelliSense doesn't really help you. You have to kind of know that, okay, delete the new keyword, and they're going to say type name dot, right? And you could imagine some experience there in IntelliSense where we promote factory methods in the constructor context, and then when you choose them, we just replace the snippet with the type name dot syntax, right? So there's a few things we could do to improve usability that are not, I think, completely esoteric or extremely unlikely. The only trouble here is that Christoph wants a solution within 2 months. And so there is a bit of a timeline issue. And even if we were to do the factory thing that we said, we can of course ship the package today. But most likely, even if the C# team wants to do extension statics for C# 9, it would ship in November next year, right? So that means, sorry, not 9, 10, I guess it is, right? Because 9 is for 5. So then the question becomes really like, okay, what timeline do we think is acceptable for those things? But I'm also not necessarily keen on shipping a Franken design just because we can't get the right design,
right.
Immediately.
Well, I mean, without extension anything, like if we did say this was a class and we got rid of all the constructors, so everything was the factories,
yep.
Which yes does lose some usability, but then gains consistency, then we can name the thing that defaults JSON, and everything is named and everything is I think that gives us better paths forward than trying to say, well, we wanted it to be a struct so we can save on the, it's a byte array and a wrapper object per return. Oh, well, that means that now we can't avoid the default constructor, which means people get confused. So the answer is don't be a struct. Like I think when we run into that language usability, it's, if we're saying this is a mid to high level type, I think we say that the usability wins out over the zero allocation.
Yeah, so the other thing that I said before, which I still think is not a bad design, is just don't have factories either, right? You could imagine a design where you just knew a binary data, and then everything is just an extension method, literally on the type instance. So you can say set bytes, right? Set from object JSON, set from stream, and then everything is discoverable. And then everything is also obviously done with, doable with today's language semantics. And we can immediately effectively say, the type is just a holder of a byte array. And we provide the JSON extension methods literally on a secondary type in a separate assembly, which I think is somewhat appealing, because that means you get the usability gains, because everything is hangs off the instance, which flows how people work in .NET, right? They say var x equals new binary data and then x dot, and then everything is there, right? And I think that would be, I don't think would be a bad design. And honestly, mutability, I don't think is really problematic here, because realistically, because you pass a pointer around, like at that point when somebody extracts data from the array, like you're basically protecting yourself from mutability already, right? Because you immediately take the data out, and then you just wrap the underlying byte array, and then when somebody else calls set on the binary data instance, it doesn't really change the underlying byte array. You're not mutating bits in the byte array, right? You're just changing what binary data points to, which I think
we're making assumptions about how their implementation works, though, because if everything that they have is backed by a ROM or a byte array, like changing things could potentially start mutating instances.
Well, if the only thing you had was set that took read-only span of byte, right? Then you're saying I am making a copy when you call this. So if you needed to do some pooling in your method, you do the pooling. I'm going to copy the data, and then you return your thing to the pool. I've used my own array on this. And then when you call the 2 bytes, which gives you the ROM byte, yeah, it's pointing to a managed array, but nothing's ever going to set data in that array again because there's no longer write access into that array.
Right. I mean, that's what
so
I'm saying. You're not really mutating the data.
Value replacement. So it is a little weird in that you can call a thing and now it has completely replaced what it's doing because they're like, oh, I can save on the object thing by just replacing the data inside this one instead of returning a new one. That would be a temptation in the hyper low allocation world, but that may be okay. It does feel that the type it gives us better composition in our current world, but it does feel like that is a definite hit on usability. But I guess if all these statics became instance and you said new binary data and then data dot from object async, that's not terrible.
I mean, it's a little COM-like, but sure, it could be okay.
I mean, that's the other thing where I think maybe it's okay to actually leave it as a struct as well. Because if all the extension methods basically just take this via in, which they can now, you actually have the right semantics when you call struct dot set from bytes or something. But then as soon as you pass the binary data around, because you actually pass a copy of the binary data, you can't actually mutate the thing it points to, right? It basically becomes immutable via that mechanism, which I think would still be good enough for usability because all you do is now, again, var x new binary data, x dot set from bytes, and then you pass this thing around. And if you do something else with that instance, it doesn't affect the other instance. And so it's not terrible either. I think it's not the ideal design I would like to ship, but it's also a design at least I can see myself shipping within 2 months without depending on some hypothetical language feature.
We could probably get away with that if we made whatever the bottom-most setter is throw if it already had data.
Sorry, what do you mean by the bottom-most?
Like, let's say that everything ultimately calls from bytes ROS byte, right? If that one then says, wait, my array field is not null, I've been initialized already, and then throws, the value can only be set once, I think that would solve all the...
Yep.
That would really solve the... You got confused by mutable struct, not like you called a method, it called set. Well, it wouldn't have done that because that would have thrown.
Yep. I think
so there's no
fine.
like you call a helper method and expect it to do something.
To be clear, I think the ROS is not going to be the bottom one because the ROS one has to copy. I think the bottom one is probably some internal one would be my guess, right? But because the fact that they're all copying, right?
Yeah, I mean that's why I said I actually think that the ROS one would be the bottom one because
you
don't want it to hold the byte array. You want it to copy the byte array, and then
that is fair, yeah.
And if everything else is built by extension methods at higher layers, they didn't have access to internal storage to set it directly. So things like the JSON serialization would need to pre-rent an array if it's trying to save on the one object allocation.
Very true.
So.
I mean, what I like about this pattern is it's easy to extend, right? And it's very consistent. It's always an instance method. If it's async, it just has an async suffix. If it's sync, it just doesn't have an async suffix. There's no like, oh yeah, sync APIs are constructors and async APIs are factories or something like that, right? Like it's a very simple pattern. And I mean, in general, like I haven't seen the usability study, but my hunch is if you have no constructors, and you just have an empty one, you just say var x equals new, the very next thing people try to do is call a method on it. Right? That's usually the pattern, right? And as soon as you see like, set from bytes, set from object, I think people will be able to figure out what to do. I'd be very shocked if they couldn't.
Yeah, I don't know if we would use, set or load or import or,
yeah. I mean, realistically, though, the thing will not have that many methods, right? We're talking about, like, as soon as you make them all instance method, you have to choose between like 10 methods, right? and they all have the same prefix, right? I think it's very obvious what you have to do.
Right. Yeah, I guess set beats 2, import beats 2, load beats 2. Yeah, as long as you beat 2, then you said new thingy, you hit dot, and at the top is the input things. Of course, if you have the IntelliCode turned on, then it may be like the most commonly called thing on this is to object. Like,
yeah,
that's not what I want.
Well, presumably we could be smart enough to say if you just instantiated one, like the very first thing you should see after a dot is set. Like that. Let's assume we can make the IDE smart enough to do that.
I mean,
I have no idea how that feature works.
Well, IntelliCode is actually doing exactly what you just said, because IntelliCode is not just ranking members when you invoke IntelliSense, it will rank members based on the surrounding code. So if the very preceding line is new, yes, I would expect like set bytes or set object to be to object. That's already how IntelliCode should work. But I also agree with you, IntelliCode has messed up my IntelliSense multiple times where I expect a sorted list, and then I look at this and I'm like, why? And to me, the worst thing is that things are out of order now because they remove the member, right? So it's not like you see some suggestions at the top, and then you have a fully ordered list. So basically a member never shows up twice, and that has totally messed up my muscle memory like multiple times. And yeah, that's something that we also have to, I think, give them feedback on as well. But yeah, I think that will be a workable design on a somewhat reasonable timeline. But what do you guys think about the idea in general? Like, are you mentally opposed, or do you think there's a valid thing here?
I mean, I'm hesitant, but I do think that if we gave it the
good old college try,
the double set block, that means that we would remove the we would be nipping in the bud the complications that come from immutable struct, because effectively we've said you build it, you get to call which named constructor you wanted, and then it's now immutable again. And so you would never have a state where you pass it to some method, it thought it was modifying something and it didn't. It will make read-only fields complicated, but again, you'll find out very quickly on that. And so I think it would work. Certainly we'd want to take I guess right now he has it as a read-only struct, so we would lose read-only on the struct, and then all the two methods would become read-only. But
yeah, that way inside of your own containing classes constructor, you can instantiate one of these, call set, and then assign the field, and then all of the two methods would just not copy as expected. Yeah, that would work.
I don't know what operators are they allowed to say read only?
Yeah, and any method can say it, including property setters or property getters, I guess.
Yeah. So yeah, I mean, it is a new, as far as I know, it's an at least uncommon pattern, but I think it is the best we can get with current language. And then, yeah, that we would take we need to figure out what we wanted to do for the JSON serialization stuff, because we probably do still want the word like JSON in the name, because otherwise, if you're ever in a universe that has both system text JSON and protobuf in your usings, and now they're both stomping on from object, then
set as JSON or set as protobuf.
Yeah, I mean, like, we would just want to start the pattern of doing it that way, so that not every serialization technology tried stomping on the best words.
I mean, if we put the extension methods that use JSON in system text.json, I think it wouldn't be terrible. Like, because then you could even have the exact same extension method names for JSON.net, and you just put them in Newtonsoft JSON, right? And you're not super likely to have a using for both Newtonsoft JSON and system text.json, because as soon as you do that, like, IntelliSense is going to be a mess anyway. And for the people who do that, at that point you just say, sorry, you have to actually call the static methods. That
right.
seems acceptable.
I think two JSON things, both saying JSON, but I think that it would not be super uncommon while anybody's in a transition period with their data to have both JSON and BSON in their imports because they're
Different things.
doing if it was in this form, we're going to load it and we're going to convert it. And so I don't think that we would want everything to just call itself from object.
I guess that's fair. So if you basically say like it's, I guess for bytes it's hard, right? Any sort of binary formatter will have binary in the name somehow, right? So you can't say the format is the higher order bit, but I guess for textual encodings, it's probably fair to say you only have to basically nail the encoding name, and then if there are multiple different libraries providing the same encoding, then we just say we give up because we don't put the full library name, of course, in the method name. And then the only thing is really like anything called binary or object that would basically compete, right? And then we have to just say, yeah, pick a good suffix and then call it a day.
Right. So, set from object JSON or set from object as JSON or something like that each. If it's a serialization thing, that it should say what it's doing. Because from stream is easy. It's reading from a stream. It's doing whatever stream.read would do. If your stream is being populated by a higher level composer, that it already made all those decisions, and you're just draining the stream.
Right.
It's only the complicated serialization ones that you would end up with. A non-degenerate application would end up with a conflict on that name.
Right.
And so that's the one that I would just want to make sure that we're defensive against. That we start with the good pattern instead of like we take the best name and then so does protobuf, and now we're in trouble.
Yeah, I agree with that. I mean, like we can basically do something similar to what we did in the HTTP client extension methods, right? And that I think has worked well. The only thing that we fucked up, in my opinion, for the extension methods was we put it in a net new namespace. That was not a great idea because I can never remember the namespace.
Fair enough.
But like, I mean, I know why we did it, but like, it was unfortunate. We probably should have put it in system.text.json. That probably would have made more sense then.
Right. And even if the extension methods for JSON live in the same package where binary data is being defined, depending on where it goes in the hierarchy, like having them be extension methods in the system.text.json namespace over binary data makes sense to me. It's not quite a thing that we've covered in the guidelines, but it feels very close to guidelines we already have.
Yeah. So then let's do this. So I will post the notes that I currently have. The other thing that we need to talk about, so so depending on what we get together, then the next question is what we ship. So let's say we do this 2-month thing that Christoph wants, then basically what it would mean is we would put this type in a NuGet package and ship it. And so basically there's 2 options we have. We can ship it in an existing NuGet package, or we can put it into a net new NuGet package. We don't really have a catch-all NuGet package today, right? We basically say every single time we backport something to NetStandard 2.0, we just ship it in a new package. That has benefits, but also has downsides, because now you have more packages in your graph, which I think is the reason why Christoph would prefer them to ship in system.text.json, because they already have a dependency on that one. But that to me seems probably okay, because if we say, like, for, when you talk about backporting, by definition, when you backport, you put something that could be low level, very high level, right? Because you ship it in a net new assembly that sits on top of everything else, right? So that's not really a concern for if you look back, but that does become a concern when you look forward. So for example, in .NET 6, do we really want binary data to basically sit at the same level as system.text.json if we went through all the trouble of making them extension methods? Because that would mean binary data itself could live in, let's say, system runtime. And then we never ever have this problem of like, oh, I'd like to take binary data here for convenience, but I really can't because it lives in system.text.json, right?
Yeah, I think that once we've moved to we can get the JSON stuff from extension methods, that we do. I don't know that we want to spike it to the bottom, but we probably do. Like it might be interesting to put this as below system.text.json, and system.text.json provides its own extension methods. I don't think we can actually do that because we're not allowed to rev the net standard contract of that package, because all those boxes that Eric can draw on a whiteboard. But actually, no, we might be okay on that one. We need to figure out whether or not we're okay on that one.
So that's the other reason why I don't like putting in a system.text.json, because system.text.json today similar to a mutable metadata reader is a you replace the entire package in .NET 5, right? So that gives us really nice characteristic because we can actually wrap the API service for system text.json in which we can't in, let's say, span, right? Because span is inbox and you can't replace it with a package. Versus in .NET 5 you can replace system text.json the package because it's you basically replace the entire module then. And so we can actually add net new APIs, and then even if you install this into .NET 5, it would just use the one that ships with your app.
Could we put this in system buffers or system memory? Could we add the type in that and not break the packages?
So could we put it in buffers? So you mean memory?
It's possible that memory is the package and buffers is the namespace, but yeah.
Yeah. So I mean, like memory is the one that ships span and all the other ones, right? And I think that one is locked. You can't do anything in that one. So my mental model is as soon as the thing has type forwards to things that ships in box, it's locked at the time you ship the type forwards. So I think memory is dead at this point. You can't rev it anymore.
Well, but okay, I'm just making sure that that's true if the package does any type forwards versus because if this new type, if we don't forward down, if it just stays in the package, then
you can replace it forever. Yes. So that means,
and then it would still have forward saying span lives in private core lib, or in the case of framework, span lives in that package, and
well, it's basically, but it's outside of.
We've changed the definition of span across like net standard 2 and any particular runtime. We've changed how it works, but we've not changed its API surface. So
right, but the problem is now.
We can do it.
So the problem is, think of it this way, right? If you deploy an application, you deploy a particular module. So the question is now, if this module exists also in the platform layer, is it safe to replace that module with the one that shipped with the app? As soon as that module has changed locations because of type forwarding, it's no longer safe to do that, right? So that's why you lock in the API surface, right? So that's why system.memory.dll you can't change, because on the down level it ships a definition, and on higher level it also on up level or later versions it just ships a type forward to the location inbox, and so you can't replace the module with a newer one that ships with the app, and so that's why it's locked, right? Versus system text.json.dll itself doesn't contain any type forwarding, right? It just depends on things that do type forwarding like span and other things, and so if you ship binary data with system text.json for 2.0, you can't say in .NET 6 binary data lives in system.runtime.dll, because that now means you can no longer safely replace system text.json with a newer version.
Right.
Does that make sense?
But I guess I'm still confused because we've never said, like, as long as we don't eventually move binary data out of living in system.memory.dll and into something lower than that, it does feel like we could add it to that package without invalidating any type forwards, because all the things that were forwarded are still forwarded.
So in order for this to be sound, right? So you basically have to have
the assembly version bumps.
Well, it's more like you don't have. So basically, you can't create a single binary system memory.dll that would work on all platforms, right? Because the thing is, on some platforms you ship a definition for some of the types, like span. And on some others, you have to do type forwarding because the types are in box. And because of that, you no longer can create a logical highest version that contains everything you want. And that's why these things are locked at some point.
But it would just be a split implementation, which I think we already have in system.
Yeah, but the problem with split implementation is you're assuming that deployment runs again, which it doesn't, right? You deployed for .NET Core 2.0, and then you happen to run on .NET 5. And so the module you deployed is now the wrong module. Because the module you deployed actually had a definition for span, but the module you needed the type forwarder for span, right? And
it's that direction of that box. Yeah,
yes.
See, this is why every time we talk about this, Eric needs to draw like 16 boxes on a whiteboard and then doodle arrows, and then we say we're never going to do this again.
Yeah, so that's what I'm saying. Like mentally, you just have to think about is there a single implementation that can just have all the features of the past and still work on older versions? And that it falls apart as soon as you have type forwards in the thing at some point. And so that's, to me, that kind of says like if you want to live in a world where binary data eventually ships in an existing DLL in box, then I wouldn't add it to system text.json, because as soon as you do that now, that vendor system text.json irreplaceable.
Yeah, I mean, that feels like the only reason we would even think about putting it there is if we were keeping the instance methods instead of extension methods, and that I think once we can decouple that, then now we're putting it there just as convenience, and as you're
Yes.
alluding to, it's actually it may be convenient today, but it's inconvenient tomorrow.
Right.
And
I
so it
also
does feel
think,
like this is a sad one type package.
right. But I think the nice thing is, like, if binary data actually becomes this, basically just this data holder, to me it lives at the same level as stream, and stream lives in system runtime, right? And so I would be okay with saying we add it to system.runtime, because the type is basically empty. Because as soon as you do that, you basically you never have a discussion ever again on like, oh, I'd like to take binary data in my arguments, but I can't because I'm lower than binary data. And so
Right. So once we put it, just thinking forward, once we put it next to stream, would we effectively, and maybe crypto's the only thing that does this, find anything that has overloads across byte array and stream and say it should also now take binary data?
I think I would be doing this only for cases where usability is super important. I think or when you really need extensibility, right? Like, I mean, even on stream, you are not very likely wanting a virtual method that takes binary data, right? Because you would just say, well, just call on the other existing virtual ones, right? So there really isn't the point of adding an overload to, read or write that deals with binary data, because as soon as you call these methods, usability is out the window anyways, because now you're in the 1 percentile per, to actually having to call the read and write methods on stream and deal with all the fallout of that.
Yeah, write or stream read couldn't use it because stream read populates a buffer instead of returns a buffer. But
and honestly, crypto is, to me, very similar. The only thing I would say is crypto, like I think we talked about this before, we just want to have a static method on MD5 and SHA-1 and SHA-212 to just basically give me the freaking hash. Do everything and give me the hash, right?
Yeah, we added that.
And so that one would be a good candidate to say, maybe that one you should have an overload that just takes binary data and returns binary data, right? Because that's really the one-stop shop where you don't care about perf, you just care about a very super simple thing, and then that one would make sense, right? And the key value here would be you basically not only take a binary data, you also return a binary data, so it's very uniform, and that would be sensible. But all the other things in crypto that deal with stream and span, I was like, no, fuck it. Like, once you call those APIs, you already like.
Right. Well, because I mean, if Christoph wants this thing to be stable in 2 months, that's even before 5, right?
So that's the other side of it. So like, in the past we have told people, including Christoph's team, that we only ship things down level once we have a design we're happy with for 5 or for the, once we have the design locked, basically, right? And so one way to lock the design is to say, well, we have shipped it, so now it's of course locked. Another way is to say we just, put it on the paper and convince ourselves that, yes, this is never going to change. The thing that we have fucked up historically is if we try to ship things out of band and then later on put the thing in box, because what then ends up happening is that the design that we shipped now constrains our future in the box, right? And that's generally not what we want to live in.
Well, because you said you would want things like SHA-256.hash to take and return one of these. Well, we just added one that takes read-only span and returns byte array. So if we wanted to do that kind of change, we would need to do that like a week ago.
Well, this is something that we would like to do for .NET 6, right? And so in order to do this for .NET 6, we would have to put binary data into the box in .NET 6, right? So now the question is, if we now ship in the next 2 months a NuGet package that ships this down level, how many design decisions have we made for that will now make our lives harder for .NET 6 without breaking compat for people that are running on .NET 5 today with that package? And that is the concern that I have, because that's the thing we usually fucked it up. And then we're like, oh yeah, if upgrade, sorry, like you have to install a newer version of the package, because unfortunately we didn't think about that. So in a perfect world, when we ship the NuGet package, we also include the ones that have type forwarders in them, so that you don't have this upgrade problem. But that very rarely happens if we ship the OOP version before the platform version. That's why we usually said, like, ship the platform version first and then the OOP after, because then you can effectively ship the NuGet package already with all the type forwards in them, so that when you're in a solution, you never have an inconsistent state.
Yeah, I mean, we could shove the thing in at 5 as at the last minute, which Jeff is probably wincing at that notion, but that's what I get for not having to be a lead.
I'm not wincing yet.
If we did, so if
Oh,
we,
Jeff
if
is
we
there.
Were happy
Hey,
with
Jeff.
it, and we shoved it in at the last moment, we could build the package as already having a forward for the net5 TFM, because the TFM exists in the graph, which is,
Right.
it would point nowhere because no one has stable net5 packages yet.
Right.
So that wouldn't be, we could still do that with the time we have left if we wanted to do that. But we would, I mean, we did just invert the data dependency flow of this object. So if we'd want Christoph to be on board, so we didn't have a big argument as we shove the thing in at the last moment.
Yeah, it's also, to me, it's kind of like if you know, if we ship a type that they don't want to take a dependency on because it doesn't realize their goals, then we just created instant legacy. So that's my other concern, is like, you know, if we, I mean, shoving it into .NET 5 seems doable, but that would be really hard. I mean, the type is small enough that I can convince myself that we could be doing that, because everything that would be complicated, we would move to an extension method anyways, and for that we have a little bit more time.
Yep.
But yeah, I mean, to me, the question really becomes, you know, without actually testing the type, what confidence do we have that we have the right type, right? And
Yeah,
like testing to me shipping it.
Yeah, we would still have the complication of, if we shove this in and we want the JSON thing, we do have to go add the JSON extension methods in system text JSON also for 5. / bump the contract for net standard 2.0, which I think it only has a net standard 2.0 contract. I think that's how we've avoided most of the complications, because we didn't split the API.
I think we actually do have I mean, we don't have a split API, but we have a split implementation for sure.
Right, but I don't think that the split implementation added net new members, and that, which means we won't get missing method exceptions. At worst, you get a perf loss.
Right, but that would also mean that we would have to ship basically not only the 5.0 implementation, also have to ship the OOP implementation at the same time, in order to really have system text.json have a uniform
right. Well,
API
I think
service.
Based on the way that it builds, that would just happen, because we would declare the extension methods, and then it would build it twice, once inbox with where it's internally calling methods that we know exist in net5, and then the other one in the
Yeah, but you still need the OOP that ships binary data, right? Otherwise, the net standard version of system text.json can't reference binary data. So you.
Oh yes, we would need the OOB to sim ship / already ship.
Yeah. So basically, we would do all 3 things at once, basically, and that's a bit aspirational at this point.
It is, but if people are motivated.
I mean, we can totally design it and then see whether we can squeeze it in.
Yep.
So the other question that I have was, so if we do this, no, I lost my question. Never mind, it's gone. Anyway, so I think this is all we had. Let's talk about this maybe in more detail later.
We can try talking about what Tanner cares about, but we probably lost quorum, since it's, you know.
And let's take a look. It's just 4
We're going to
methods.
have confirmation bias with just us.
I mean, I've never seen the API, so I'm still unbiased. So you can convince me, and if I'm hesitant, then you at least have half the value of the meeting.
I think even with the people, we have quorum because it's essentially methods we already expose for float and double, but with half. So I'm pretty sure we can come to an agreement on it.
Okay, I mean, we can look. I'm just calling out that we started with not a great number of people, but we also didn't have to make real decisions, and now we have even fewer people.
Oh, do you want to talk about it, Tanner? Like, I mean, I'm already sharing my screen. I'm not sure whether the screen updates at this point because.
What's the issue number?
It's 41318.
All right, so we had already approved a number of half APIs to Bitconverter and other places. But these 4 were basically missed. They're the Bitconverter methods for writing to byte arrays and spans respectively, and for getting the raw byte array or span of bytes back out. They mirror the existing ones that we take for single and double.
So 2 half, we have 2 single and 2 double. Overloaded and skip bytes. What conversions exist from half?
There's an explicit conversion to single. In the future, the language may implement implicit conversions there.
But since it's an explicit conversion right now, there's no one, even in current previews, etc., would have called bitconverter.get bytes and it up converted to single or double.
Correct. Which is also why we made them explicit, so we wouldn't have compat issues if the language decides to implement it in the future.
What happens if you have both implicit and explicit conversion to a type and you cast?
Well,
I think
believe in that case, it will
intrinsic
say,
and an explicit, and then the intrinsic would win.
yeah. Well, technically, due to the way half works, it would be an explicit method in either case. But if you define both an implicit and explicit, and you explicitly cast the explicit version, wins.
Really?
Yeah.
But if they define it as an intrinsic numeric cast, that one would win, right?
Probably.
Or would it the parentheses and call the explicit version?
It would depend on how they implemented it, but there is no way to implement an intrinsic version for this because there's no IL for it. It's a user-defined type, effectively. It's like decimal.
Okay.
So
the language would internally say, I have a concept of a language implicit and a language explicit, and then they can map it however they want. But if they only defined a language implicit, and there was a user-defined explicit, the user-defined explicit wins because they don't have a language explicit version.
Gotcha.
Yeah.
And I mean, like, I guess the other thing is, yeah, if you said if it's user-defined type, you have to call the method at the end of the day anyway. So you can't just have a language one. You actually have to decide what code execute when you call it. So then the question becomes, So we will ship an explicit one then?
Yeah, we're shipping explicit conversion to and from single and double.
Interesting.
Yeah, this looks like pure logical overloading to me. It seems fine unless someone like Jan is trying to keep half out of places like this.
As far as I know, we're not, especially since we already reviewed, approved, and Jan just signed off on the other bit converter overloads, like the half to int16 methods.
Okay. So,
I mean, these look all fine. I mean, they're like, yeah, considering how the existing APIs are factored, like that seems very consistent.
yeah. Seems. I think Tanner is right. It doesn't really matter how many of us are here. We really have no reason to say no unless there's layering. And if Jan signed off, then I don't think anyone will complain about layering.
With us, half ship and system runtime, I suppose, right?
Yeah, because we're eventually going to add intrinsic support and other bits to it, which I need to get the proposals up for.
Gotcha. And there's no language support whatsoever, right, today?
Yeah, none today, and it's not clear when or if they will add it in the future.
And so that means also today we don't have any operators either, right? It's just purely a data holder.
Correct.
Okay. So for decimal, because you compared it to decimal, for decimal are things like addition defined by the language as opposed to by custom operators?
So the way it works is because there's no IL for it, the actual implementation is defined in managed code. So it's written in C#. You can actually go and use reflection to find op addition. But the language has an internal operator table that says the language supports the concept of adding two decimals together. It happens to be implemented as a call to op addition, but it follows the language rules, which means there's special scenarios around implicit conversions and other things where it functions differently from a normal user-defined operator, which has no language support.
Okay. So it's if half gets good language support, then it would gain the operators that the language says that they want it to have.
Yeah, and those operators would be implemented in managed code as part of the shipping library. And if they were missing, the language would fail to compile.
So right now, if someone needs to add two halves, they need to raise them to a higher type, add them, and then shove it back down on a half box?
Correct.
Okay.
And it's presumably that's what we would do in the methods anyway, right?
Yes. And then for some platforms like ARM64, there would be hardware support to actually use the hardware instructions to do it.
Gotcha.
For x86, there's only hardware acceleration for upcasting and downcasting.
That makes sense. All right, so then I think this is it for today. We actually got everything done that we wanted to get done.
Sort of.
What did you want to get done that we haven't covered?
Well, I think Christoph would have been much happier with an improved design for his thing instead of he had to leave and we only talked about it and now we're bouncing it back to him. But
well, I mean, like I talked to him yesterday. I mean, like he didn't have an expectation we would approve it today. Like, I mean, he wanted to plant the seed. I mean, like I think he reached his goal. Like we didn't say no, and we already tossed around ideas how we could do it. We just have to design it.
right.
So the question I think there is like what are the next steps? Like who owns the type right now? I mean, I'm happy to like sketch the design that I roughly talked about, and then see how he reacts to that.
Yeah, I think that sounds like a good next step. So figuring out, just pick a straw man verb that you want for the setter, and then put a comment somewhere that it's functionally init only. So calling set twice will throw, which will stop mutable struct complications from showing up in the real world.
Right, and then so Jeff, like out of curiosity, if we were to put it in, like what timeline do we have to do it? That sounds like a lot.
Given that Christoph has some friends with a lot of push.
Yeah, so our RC1 is done tomorrow at noon. RC2, we're just going to go directly into Async mode for RC2. Based on Tactic's decision this morning, we're not going to downgrade back to an M2 approval. So we're in Async mode here through the end of the release. End of this month is when we're locking GA. So the sooner the better. But at this point, we've already missed RC1.
Yeah, I think RC1 makes sense. I didn't expect RC1 to be something we could do, but like
RC2 officially snaps on the 14th, I believe.
So we have effectively, a week and a few days to shove it in if you want to react to issues.
Yeah.
Well,
14th for RC. Oh, I'm sorry. Actually, I take it back. RC2 snaps on the 4th this Friday. And then it goes into validation mode on the 14th.
Yeah, so I mean, it still can be directly pulled into the branch, but RC2 is, I think, essentially past feedback. Like, people need to give feedback on like the day it comes out, or we've missed the window.
Yeah.
It's not a. I mean, it is hard because it's we shove it out and then we're effectively now locked down for RTM. It's super critical bugs only at that point.
I mean, I
would venture a guess, and I would say, knowing Steve, I'm pretty sure he will say no, because he would basically say it is not the spirit of RC2, right? Because as you said, like you can't get feedback on it. You can only make changes you know will work, and shipping a feature that we have only convinced ourselves in a meeting room is the right shape is not meeting that bar. So I'd be shocked if he would agree with that.
I agree.
Which could mean that effectively, Azure gets to decide what Azure wants it to look like, and for the next version, or as a OOB in the middle, we can make the BCL version of it, and then they just need to add an implicit conversion from the BCL one.
Well, they don't want to do breaking changes either, right? So, like, I think the best we could do is only ship an OOB, but ship it in a way that we can type forward into system runtime later, right? But it will still be a source breaking change at the time we ship .NET 6. You have to rebuild to .NET 6 to get the right behavior. Otherwise, you end up with duplicate types. But that's fine.
Well, that means that if you built net standard, are you saying you would crash on 6?
No, you wouldn't crash. You would not be able to build on 6. So let's say you're building. So let's say today we ship this new get package, right? It has a definition for binary data, and then there's another type that has the extension methods that lives in system text or JSON, right? So we ship a new get package system.binary data has one assembly in it and one type in it, right? And that assembly we only have a single implementation for it today, which would be net standard 2.0 that just ships the definition, right? Because we haven't shipped .NET 6 yet, so there's nothing for us to type forward to. So now you have your project, everything works today. 12 months from now, you're upgrading your project in the project properties from net 5 to net 6, and you try to rebuild. As soon as you try to do this, now you have two binary data, right? You have one coming from the package, and you have one coming from the platform. And for you to solve this problem is we have to ship a new version of that package that has a net 6 asset that type forwards, and then the user has to upgrade his package from the one that we ship today to the one that we will ship 12 months from now.
Okay, so it would be you have to upgrade the package to get the forward if you're compiling against the net 6 TFM. That
is correct. And so
but if you were compiling against net standard or the net 5 TFM, things will unify correctly at runtime.
Because net 6 will ship system.binarydata.dll as a type forwarder, right? But this DLL will now ship in box of a higher version, so we would load the one in box, not the one that comes from your application. And so at runtime it would work. But at build time you get into a state where stuff doesn't build right. But there's nothing for us to do. I mean that's the downside of shipping before we ship the platform.
Right. That seems. I was afraid you were saying that if you built it as net standard and then loaded it into net 6, that it would explode. But as long as we make that work, I think that the rebuilding your package and getting the higher version, like as long as you're building a new thing, it would already pull the highest stable version. So it may be generally okay.
Yeah, I mean, it's not great, but I think it's acceptable. It just means also so keep in mind that also means if you install, let's say, the Azure SDK into .NET 6, you might still result immediately in a configuration that doesn't build, right? Because it depends on who depends on this package and what version are they expressing it at, right?
Right, but we could, for example, just thinking ahead, we ship it as OOB now through whatever mechanism we can ship it as OOB.
Right.
In master, we go ahead and declare the thing. At some point, we're going to push the net 6 TFM into the TFM graph, and as soon as we do that, we could bump the package. So there's already the notion of a net 6 forwarder sitting out there for a very long time.
Yes, that is true. We can limit the time window where people have shitty packages. That is a fair statement.
Yeah, and if we've already published that there's a net 6 TFM, then we could go ahead and put the forwarder there. No one would have a net 6 runtime, so they wouldn't hit the problem of it not making sense. Ideally, we would have already done the work, so we didn't find that we did the type forward incorrectly. But I think that if that's the problem, we can solve that with a forward-looking package with just making sure that we stay on our toes.
Right. I mean, it depends on how we want to skin this cat, right? I mean, I would probably be even okay with going a step further and say the first version of the package that we ship already has that shit in there. Because
Right,
I mean,
and
because we can already build for
as
.NET
the
6, right?
can exist. I guess that's true. We don't even need the TFM to pre-exist. We just need it to be in the package so it resolves right.
Right. And we know what the version number is. We know what the name is. So like, I mean, it's not. I mean, given that we are shipping out of system runtime, sorry, of .NET runtime, we can already build for .NET 6 anyway, so we don't have to wait for anybody. It's just, yeah, it's one of those things that you get one shot at getting right, and then at that point you just talk about people.
Yeah, I don't know how we would do the JSON without. Like we could ship a package out of band whenever we want, but we would need the system text JSON update in order to get those extension methods.
Well, the nice thing is for JSON, it wouldn't really matter, right? Because the way JSON would work is that the extension methods would live in system text.json.dll, and that would be the case for .NET 2 as well as for .NET 5 or 6 or whatever.
We need to publish another stable version of that package, slightly off cycle.
That is true. Yes, you would have to ship a new version of that package.
So it would require that little bit of political clout.
But we've done it before, right?
It's an empty package and revving another one. I don't know that we've ever done that without servicing.
Oh, I see.
Like we just need to figure out what the logistics of that is. I don't know if that would be Eric St. John or what, but
probably
the easiest answer would be we just check it in and it goes stable with 5.
Right.
But that requires the ship room approval, which you could get if you say, well, we're going to do this off cycle around that time anyway. It's just easier for everyone involved if we check it into this tree.
Right.
So yeah, I think with those notes, see what Christoph wants to say, because if he's on board, then I think that there's enough time that we can make something happen. And if it goes back and forth too many times, then the 2 months are up anyway.
Sounds good. All right, then I'll see you guys later.
Auf Wiedersehen.
Auf Wiedersehen.